given that the function y is equal to 1 over x, so that y differentiated is equal to negative cosine x cot x. We are going to use method 2, which is called quotient rule. Method 1 was about the power rule. You can check it in my channel through the link indicated below. So we let our numerator to be u, which is equal to 1, and when we differentiate any positive number with respect to x, we are going to get 0. Then our denominator, we are letting it to be function v, which is equal to sine x, and when we differentiate v with respect to x, we are going to get on the right side sine x differentiated is equal to cos x. The quotient rule tells us that when we are differentiating two functions, the formula is the first function differentiated times the second function minus the first function multiplied by the second, the derivative of the second function divided by the square of the first function. So we substitute u prime, u differentiated is 0, we substitute it there, multiplying by v, which is sine x, we multiply there, then minus u, which is 1, multiplying by v differentiated, which is cos x. Then from there we simplify. Any number multiplying by 0 is 0, so 0 times sine x is 0, minus 1 times cos x is equivalent to as negative cos x. A positive number times a negative number times a positive number is equal to negative, so that is where there is a negative there, divided by sine x squared. But we know that cos x over sine x is equal to cot x. Also, 1 over sine x is equal to cosine x. Because we can split here, this one can be written as cos x over sine x times 1 over. So here we substitute, instead of negative cos x over sine x, we are going to write cot x, and instead of 1 over sine x, we are going to write cosine x. And when we write that, the result will be y differentiated is equal to negative cosine x times cot x, which is the end of the proof which we had been shown to show. So thank you so much for watching. Welcome even as we continue with our study, whereby we are looking at the basics of calculus, and we are deriving the derivative of trigonometric function, so that even as we are going to apply them in advanced studies of derivative, you will be aware on how to obtain them easily using the quotient rule and also the product rule to get the same. So for more studies, kindly like and consider subscribing to the channel, because much more is waiting for us as we continue with our study. You can get the same result by use of the power rule as I have done it in other study. So I'm going to give you the link in the description box, which you can follow and also know how to apply the power rule to get the same result of the proof of this function. So bye bye. We are going to meet next time, even as we continue with our study, which focuses on calculus and also other part of applied mathematics. But in this season, our focus is on calculus and more particularly on the derivative of trigonometric functions, which are very important in the study of applied mathematics. So you can always reach me through my YouTube channel, whose name is my YouTube channel name is Luke Aaron, as indicated there. So check the spelling because there are so many Aarons, but my channel name is as written there, Luke Aaron. Bye bye. See you next time.